Welcome to this video tutorial on the focused one multiplexer in Verilog. In this video, we will cover the concept of a focused one multiplexer, its design, code implementation, and real-world application. Let's get started. First, the definition. A focused one multiplexer is a combinational logic circuit that selects one of four input signals and routes it to a single output line. It uses two select lines to determine which input is passed to the output. The select lines control which data input will be outputted, essentially acting as a data selector. Now let's look at the block diagram of focus 1 multiplexer with 4 input, 2 selective line and 1 output. Let's move on to the truth table. For the focus 1 multiplexer, select lines of S1, S0. The input I0, I2, I3. When S1 and S0 are 0, 0, the output will be I0. When S1 and S0 are 0, 1, the output will be I1. When the S1 and S0 are 1, 0, the output will be I2. When the S1 and S0 equals to 1, 1, the output will be I3. Let's look at the logic circuit diagram and the equation. The logic circuit diagram uses AND gate, OR gate, and NOT gate. Each gate, AND gate, is activated based on the values of the select lines, and the output is a combination of these AND gates using an OR gate. The logic equation for the 4x1 multiplexer is given below. This equation clearly shows how the select lines determines which input is routed to the output. Open your browser and search for EDA Playground. Once on the platform, you will see the main interface. On the left side, locate and select the Tools and Simulation section. From the drop-down list, choose iCare's Verilog 12.0 as the simulation tool. Now in the text editor on the platform, write your Verilog design code. Next, write test bench code to simulate the design. Once done, click on Run to execute the simulation and check the result. Now let's dive into the Verilog design code and test bench for 4x1 multiplexer. Here is the design code for the 4x1 mux in Verilog. First, we declare the module for 4x1 multiplexer. This defines the name of the module and specify that it has input and an output. Next, input and output declaration. I3:0 is the 4-bit data input to the mux, where each bit represents a different data line. Select I:0 are the two select lines used to control which input is passed to the output. Y is the 1-bit output that carries the select input. Always block. Next, we have the always block line in the code. This block monitors changes in the select lines. Based on the values of the select line, the block decides which of the four inputs should be assigned to the output. End module. Finally, we end the module with the end module statement, which marks the end of the 4x1 multiplexer design. Next, we have the test bench code, which will apply various input combination and test the functionality of the mux. First, we declare the test bench module, which is where we will simulate the functionality of 4x1 mux. Input and output declaration of this code. We declare the input and select lines as rect types, since we will be applying different test values to them. The output is declared as a wire which will display the mux output during the simulation. Then we instantiate the 4x1 mux using the identifier UUT, that is unit under test. This step connects the input and output for simulation and helps with port mapping between the test bench and the design module. Inside the initial behind block, we define the test sequence that will apply different combination of input and select lines to mux. Additionally, we initialize waveform generation. We use the dump file command to generate a file for visualizing the output waveform. This file can be viewed using GTK Wave or any other waveform viewer. The test cases assign values to the input and select lines, allowing us to check whether the mux correctly select the corresponding input based on the select lines. Finally, We use finish to end the simulation after all test cases are executed. Now look at the output waveform. After simulating the test bench, we get the following output waveform. Here, when selector line is 0, 0, the output will be I0. When the selector line is 0, 1, the output will be I1. When the select line is 1, 0, the output will be I2. When the select line is 1, 1, the output will be I3. This shows that the multiplexer is functioning correctly by selecting the correct input based on the selectors. Finally, let's talk about the application of the Focus 1 Max. It is used in various fields like data routing, digital circuit design, memory addressing, and signal control, etc. Thank you for watching. I hope this video helped you to understand the Focus 1 multiplexer, its design and applications. If you have any questions, feel free to leave them in the comments below. Don't forget to like, share, and subscribe for more tutorials like this.